Dear students, you are welcome in the Education Department at SHAHD Association. Our lesson today is Structure of Atom. Make sure to subscribe to our channel for more lessons and don't forget to activate the bell to stay notified.
Our objectives in this session are: we will define atom, we will list the subatomic particles in each atom, we will define atomic and mass number, we will calculate the number of neutrons, we will calculate the charge of the nucleus, and also we will calculate the charge of electron cloud, and finally we will define isotopes.
In the Explore section, we talked a little bit about the small particles of the sand castle. Our lesson today will be about smaller particles that are called atoms. But first, let's make a simple introduction about the atoms. Atoms are tiny basic building block of matter. All materials on Earth are composed of various combinations of atoms. Atoms are the smallest particles of chemical element that identify the properties unique to that element.
The second part of our lesson is identifying the components of an atom. Atoms consist of two parts. The first one is called the nucleus. It is located in the center of the atom. It is also the massive part in the atom. Massive means that it has the higher mass. The second part of the atom is called the electron cloud. The electron cloud is orbiting about the nucleus.
Now, we will identify the three subatomic particles that exist in each atom. Atoms contains subatomic particles that are called protons, neutrons, and electrons. This picture to the right, it shows the three subatomic particles and their location. Protons and the neutrons, having the color of red and green, they are located in the nucleus, while the electrons, which having the color blue, they are located on the electron cloud. What is the atomic number and what's the mass number? The atomic number is defined as the number of protons that are present in the nucleus. The atomic number identifies the element. The mass number is the combination of the number of protons and neutrons that are present in the nucleus. Out of these two numbers, we can calculate the number of neutrons by applying this rule. So the number of neutrons is equal to the mass number minus the atomic number. How can we symbolize the chemical element? So the general symbol of a chemical element is X, A, Z. X is the chemical symbol of the element. A is the mass number and Z is the atomic number. Let's take an example for that. So the helium atom. The helium atom, it has a symbol of He. Its mass number is 4 and its atomic number is 2. So we can write as A is equal to 4 and Z is equal to 2. Out of these two numbers, we can calculate the number of neutrons by applying this rule. So the number of neutrons is equal to the mass number A minus the atomic number Z. So if we substitute, so 4 minus 2, we will get a 2 as an answer, and so we have 2 neutrons.
We previously listed the subatomic particles. Now, we will tell the charge of each subatomic particle. Protons, they are positively charged. They have a positive sign. Neutrons, they are neutral. They do not have a charge. Electrons, they are negatively charged. They have a minus charge. The charge of one proton is plus 1. The charge of one neutron is 0. The charge of one electron is minus 1. The charge of the total number of protons is the number of protons times the charge of one proton. The charge of one neutron is the number of neutrons times the charge of one neutron. The charge of all electrons is the number of electrons times the charge of one electron. Let's do an example. In the right bottom, we have a picture for a chlorine atom. From this picture, we can write the given. We have 17 protons and we have 18 neutrons. If we count the dots on the electron cloud, then we will have 17 electrons. The first question is that we have to calculate the charge of the nucleus. Then we have to calculate the charge of electron cloud. The charge of the nucleus is the charge of the protons plus the charge of the neutrons. The charge of all protons is the number of protons times the charge of one proton. And the charge of all the neutrons is the number of neutrons times the charge of one neutron. So if we make the calculation, 17 times plus 1 is plus 17, plus 18 times 0 is 0. So if we add up, the answer will be plus 17. The charge of the nucleus is plus 17. Now, let's calculate the charge of the electron cloud. The charge of the electron cloud is the charge of the electrons. The charge of all of the electrons is the number of electrons times the charge of one electron. The number of electrons is 17 times the charge of one electron is minus 1. So 17 times minus 1 is minus 17. This is the charge of the electron cloud.
Previously, we said that the electron cloud is one of the components of an atom. Now we will take in deep what's an electron cloud. Electron cloud is made up of shells. Each shell is made up of subshells. In this lesson, we are only interested in the shells. We have 4 shells known as the K shell, which hold a maximum amount of 2 electrons. The L shell, it holds 8 electrons as a maximum amount. The M shell, it holds 8 electrons. The N shell, it holds 2 electrons. The number of electrons that the element has or the atom has are distributed on these shells. To make the electron configuration clear, we will make the following example. We have 3 atoms. The sodium atom that has atomic number of 11. The chlorine has atomic number of 17. And the potassium, it has atomic number of 19. In this example, we don't have the number of electrons. But previously we know that for a neutral atom, we have the number of electrons is equal to the number of protons, which is equal to the atomic number. So sodium, it has 11 electrons. We will distribute these 11 electrons on the shells. So 2 is taken by the K, 8 taken by the L, and what remains, which is 1 electron, is taken by M. K2, L8, M1. The chlorine atom, it has 17 electrons.
2 is taken by K, 8 taken by L, and what remains, which is the 7, is taken by the M. K2, L8, M7. The final one, which is potassium, it has 19 electrons. 2 is taken by K, 8 is taken by L, 8 is taken by M, and what remains, which is 1 electron, is taken by N. So K2, L8, M8, and 1.
The final idea in this session is defining isotopes. What are isotopes? So as a definition, isotopes are the atoms of the same element that have the same atomic number but they have different mass number. These three hydrogen atoms, they have the same atomic number 1, but the first one it has 1 as a mass number, the second one it has 2 as a mass number, and the third one it has 3 as a mass number. These three atoms are called isotopes because they have the same atomic number but they have different mass number. As a summary, what we talked today. We talked about the structure of the atom and we said that we have two components, the nucleus and the electron cloud. We also talked about the subatomic particles of each atom and their charges. We calculated the number of neutrons from the atomic and mass number. And finally, we defined isotopes and we took an example of an isotopes. Thanks for watching. If you liked this lesson, make sure to subscribe to our channel for more. And don't forget to click the bell to get all updates.